Imagine a car that doesn't need gasoline, doesn't need electricity, and doesn't produce any emissions at all. Instead, it runs on something you breathe every single day: compressed air. It sounds like science fiction, but for decades, scientists and engineers have been working on a car powered entirely by air. No fuel tank, no batteries, just highly pressurized air stored in a tank and used to move pistons or turbines. And the best part? It works. The idea isn't new. The first patents for air-powered motors date back to the late 1800s. In fact, some early industrial machines and even mining locomotives used compressed air as a safer alternative to steam engines. But building a lightweight, efficient, air-powered vehicle was always out of reach. The materials weren't strong enough. The tanks were too heavy, and the energy losses were too high. That started to change in the early 2000s. New materials, advanced composites, and better control systems made it possible to store air at extremely high pressures, sometimes over 300 times atmospheric pressure, and release it in a controlled way. Suddenly, a car running purely on air didn't seem so impossible anymore. One of the most famous attempts came from a French company called MDI. They developed a small city car called the AIRPod, a three-wheeled lightweight vehicle that runs entirely on compressed air. It was designed for short city commutes with a top speed of around 50 miles per hour and a range of up to 125 miles. The air tanks could be recharged in just a few minutes using a high-pressure compressor, or slowly overnight using a small electric pump at home. The benefits were clear. No fuel, no emissions, no battery degradation. Just clean air in and movement out. In terms of daily use, the cost per mile would be a fraction of what even electric vehicles offer today. And with no combustion and no flammable liquids, the safety profile was excellent. So why didn't it take off? The biggest challenge is efficiency. When you compress air, a lot of energy is lost as heat. And when you release that air to do work, even more energy is lost. The round-trip efficiency from electricity to compressed air to mechanical motion is low, typically between 10 and 15%. For comparison, electric vehicles powered by lithium-ion batteries can achieve over 90% efficiency under ideal conditions. The second challenge is pressure. To get useful power, air needs to be stored at extremely high pressures, over 3,000 psi. That requires strong, often expensive tanks made from advanced materials. While modern composites have improved safety and reduced weight, they also raise production costs and regulatory hurdles. Then there's performance. Air-powered engines generally produce less torque than combustion or electric motors. That limits acceleration and makes it difficult to operate the vehicle in hilly or high-speed environments. And finally, there's the economics. The AIRPod was supposed to launch commercially more than a decade ago. Tata Motors, a major Indian automaker, even invested in the project. But delays, cost overruns, and technical setbacks stalled the rollout. Production was postponed again and again, and confidence in the technology started to fade. But the idea isn't dead. In fact, engineers and researchers around the world are still exploring ways to use compressed air as a clean energy solution, either for vehicles or for stationary energy storage. Some hybrid concepts combine air and electric power, using compressed air for short bursts and electricity for longer range. Others imagine using air in industrial zones, airports, or closed environments where emissions must be minimized. Compressed air is also being tested as a form of grid-level energy storage, taking in excess electricity from solar or wind farms, compressing air, and storing it in underground tanks or sealed chambers. When energy is needed, the air is released through turbines to generate electricity again. It's less efficient than batteries, but also much cheaper, longer lasting, and easier to maintain. So why should we still care about air-powered cars? Because they remind us that alternatives exist. Not every solution needs to be electric. Not every future needs lithium. In a world where clean energy is becoming more important than ever, and where battery production raises its own environmental issues, compressed air offers a simpler, lower-impact option. Yes, it may not power sports cars or long-haul trucks, but in cities for short distances or in specific use cases, it might still make sense. A fleet of lightweight air-powered taxis, delivery pods, campus shuttles, even forklifts or airport vehicles. Anywhere where speed isn't the priority, but cleanliness and simplicity are. The idea of an air-powered car also pushes us to rethink energy in broader terms. Energy isn't just electricity. It's motion, pressure, temperature, potential. And compressed air, despite its limitations, is a form of potential energy that we've barely begun to explore. In the long run, electric vehicles will likely dominate. Their efficiency is hard to beat, and the infrastructure is already growing. But that doesn't mean we should ignore alternatives. Compressed air cars may not be the future of transportation, but they could be part of it. The bigger lesson is this: innovation doesn't have to mean more complexity. Sometimes it means going back to the basics and doing them better. And when the world is trying to clean up its act, that might be exactly what we need. Subscribe us for more videos.